Integral calculus. Part A. Integration by substitution. This is essentially the reverse of the chain rule. Recall that the chain rule says, the derivative of f of g of x equals f prime of g of x times g prime of x. Running this backward, if we see an integral of f of g of x times g prime of x dx, we can substitute u equals g of x, so du equals g prime of x dx. The steps are, identify the inner function, let u equal that function, find du, replace everything with u, integrate, then substitute back. Let us visualize what substitution does. Consider the integral of 2x times e to the x squared dx. The integrand, 2x times e to the x squared, looks complicated in the x domain. But when we substitute u equals x squared, du equals 2x dx, the integral transforms to simply the integral of e to the u du in the u domain. This is just e to the u plus c, which equals e to the x squared plus c. Substitution simplifies the function by changing variables. Example 1, find the integral of sine of 3x plus 5 dx. Let u equal 3x plus 5. Then du equals 3 dx, so dx equals du over 3. Substituting, we get 1/3 times the integral of sine u du. The integral of sine u is negative cosine u. So our answer is negative 1/3 cosine of 3x plus 5 plus c. Example 2, find the integral of x over the square root of 1 plus x squared dx. Let u equal 1 plus x squared. Then du equals 2x dx, so x dx equals du over 2. The integral becomes 1/2 times the integral of u to the power negative 1/2 du. Using the power rule, this gives us the square root of 1 plus x squared plus c. Here is the graph of the integrand, and the shaded area represents the integral. Part B. Integration by parts. This method comes from the product rule of differentiation. The product rule says d by dx of u times v equals u times v prime plus v times u prime. Integrating both sides and rearranging, we get the formula, integral of u dv equals uv minus integral of v du. The key question is how to choose u. Use the ILATE rule. The function that comes first in the order ILATE should be chosen as u. I stands for inverse trigonometric, L for logarithmic, A for algebraic, T for trigonometric, and E for exponential. Here is a beautiful geometric interpretation. Think of u times v as the total area of a rectangle with sides u and v. This total area can be split into two parts, the integral of u dv, shown in blue, and the integral of v du, shown in red. Since the two parts together make the whole rectangle, we get integral of u dv equals uv minus integral of v du. This visual helps you remember the formula. Example 1, find the integral of x times e to the x dx. By ILATE, x is algebraic and e to the x is exponential, so we choose u equals x and dv equals e to the x dx. Then du equals dx and v equals e to the x, applying the formula x times e to the x minus the integral of e to the x dx. This gives us x e to the x minus e to the x plus c, which factors as e to the x times x minus 1 plus c. The graph confirms, the blue curve is x e to the x, and the green curve is its antiderivative. Example 2, find the integral of x squared ln x dx. By ILATE, logarithmic comes before algebraic. So we choose u equals ln x and dv equals x squared dx. Then du equals 1 over x dx, and v equals x cubed over 3. Applying the formula, x cubed over 3 times ln x minus the integral of x cubed over 3 times 1 over x dx. This simplifies to x cubed over 3 ln x minus 1/3 integral of x squared dx. Computing this gives us x cubed over 9 times 3 ln x minus 1 plus c. Part C. Integration by partial fractions. When we have a rational function p of x over q of x, and the degree of the numerator is less than the degree of the denominator, we can decompose it into simpler fractions. Each simple fraction like a over x minus a can be integrated directly using the natural logarithm. The integral of 1 over x minus a is ln of the absolute value of x minus a plus c. For repeated factors, 1 over x minus a squared integrates to negative 1 over x minus a plus c. And for irreducible quadratics, we get inverse tangent terms. There are 4 main types of partial fraction decomposition. Type 1, distinct linear factors. For example, if the denominator is x minus a times x minus b, we write a over x minus a plus b over x minus b. Type 2, repeated linear factors. If we have x minus a squared in the denominator, we need both a over x minus a and b over x minus a squared. Type 3, an irreducible quadratic factor like x squared plus b gives bx plus c over x squared plus b. Type 4, repeated quadratic factors need similar treatment. In G, types 1 and 2 are the most frequently tested. Example 1, find the integral of 1 over x minus 1 times x plus 2 dx. We decompose into a over x minus 1 plus b over x plus 2. Multiplying both sides by the denominator, 1 equals a times x plus 2 plus b times x minus 1. Putting x equals 1 1 equals 3a, so a equals 1/3. Putting x equals negative to 1 equals negative 3b, so b equals negative 1/3. Now we integrate each simple fraction, 1/3 ln of x minus 1 minus 1/3 ln of x plus 2 plus c using log properties. This is 1/3 ln of the absolute value of x minus 1 over x plus 2 plus c. Example 2, integrate to x plus 3 over x plus 1 times x squared plus 1. Since x squared plus 1 is an irreducible quadratic, we decompose as a over x plus 1 plus bx plus c over x squared plus 1. Putting x equals negative 1 1 equals to a, so a equals 1/2. Comparing coefficients of x squared gives b equals negative 1/2. Comparing constant terms gives c equals 5/2. Integrating each term, 1/2 ln of x plus 1, minus 1/4 ln of x squared plus 1, plus 5/2 are 10x, plus c. Notice the graph has a vertical asymptote at x equals negative 1. When should you use each method? If you see a composite function with its derivative present, use substitution. If the integrand is a product of two different function types, like algebraic times trigonometric or algebraic times exponential, use integration by parts with the ILATE rule. If the integrand is a rational function, a polynomial divided by another polynomial, use partial fractions. Sometimes you may need to combine methods, for example, partial fractions followed by substitution for each term. Here are 8 essential tips for your exams. Tip 1. Always try substitution first, it is the simplest method. Tip 2. Use the ILATE rule to choose u in integration by parts. Tip 3. For partial fractions, the degree of the numerator must be less than the denominator. Tip 4. If the degree of p is greater than or equal to q, perform polynomial long division first. Tip 5. The cover-up rule quickly finds coefficients a and b. Tip 6. For repeated integration by parts, try the tabular method. Tip 7. Never forget plus c in indefinite integrals. Tip 8. Always verify your answer by differentiating it back. Keep these formulas handy. If you found this helpful, like and subscribe to MAGPIEHUB for more G and board exam solutions. See you in the next video.